Colonel William McWhorter pulled back on the control yoke and eased the lightly loaded B-17 Flying Fortress off Eglin Air Force Base's long runway. It was a beautiful flying day, a light wind from the east, visibility was 15 miles. McWhorter circled while his charge, another lumbering B-17 painted bright orange, took to the skies behind him, under radio control from his crew of 6 engineers. This was likely to be the drone B-17's final flight, if, at least, the weapon that he was here to test worked as advertised. With the drone following obediently behind, Colonel McWhorter turned out over the Gulf of Mexico, cruising along at 10,000 feet in the clear sky. Somewhere out there, approaching at speed, was another plane, a jet packed with technology and firepower, a Sabre Dog. A tragedy was about to occur. The F-86D Sabre Dog has its origin in the same crisis of interception that birthed the F-94 Starfire. In 1948, the emergence of the Tu-4 Bull in the Soviet Union and a series of disastrous tests of US air defense readiness resulted in a crash program to fill the gap in interceptor availability. The F-89 Scorpion was years behind schedule, legacy piston-engined all-weather fighters had marginal value, and existing jet fighters were useless in bad weather or at night. Suddenly motivated to fill the gap, the Air Defense Command would eventually launch 2 programs aimed at modifying existing day fighters for all-weather operations. The Starfire was based on the T-33, essentially a twin-seat version of the P-80 Shooting Star. Although it would go on to have a long and successful career as a trainer, the T-33 was already obsolete as an air-to-air fighter. Its straight wings restricted its speed, and no amount of additional turning performance or stability could make up for that deficiency in the rapidly evolving tactical air combat domain of the late 1940s. Fortunately for the USAF, another air superiority fighter was just entering service. Although Korea and its rise to legendary status was still ahead of it, the Air Force had high hopes for the F-86 Sabre. It clearly had the performance that the P-80 and P-84 lacked. There were, however, a couple of issues with the Sabre as an all-weather interceptor. Although it had a significant maneuverability advantage over any proposed bomber, not a given with transonic fighters in the period, it lacked range, its climbing performance was average, and its small airframe, cut by a giant air intake, made it hard to pack in the required avionics. The latter was a particular problem. The Sabre was a single-seat fighter and initially didn't have a radar of any sort. An all-weather fighter needs search and attack radar to be effective, and the radar technology of the time was very crew workload intensive. Humans were in the loop for every function. A second crewman was the obvious consequence of this complexity. He could manage the radar and navigation and leave the flying and firing of the weapons to the pilot. But North American aviation were undaunted by this challenge, and why should they be? They were in the middle of an outstanding creative period in which they would develop 3 of the most successful fighters of all time, the P-51 Mustang, the Sabre itself, and the F-100 Super Sabre. On March 28, 1949, they set about modifying the F-86A into an all-weather interceptor. Within a matter of days, the USAF showed interest in the project, I imagine via a few strategic cocktail parties in Washington. And North American felt sufficiently confident that they began work on a production version on April 7, 1949. The aircraft they ended up developing didn't really bear much resemblance or indeed have much in common with the F-86. Eventually only the wing would be shared between the interceptor and fighter versions of the Sabre. In fact, the Air Force's original intention was to call it the F-95, but post-war defense spending cuts meant that the pragmatic thing to do was to claim that this was just a new version of the Sabre. The YF-95 soon became the F-86D. First to get the chop in the new design was the engine. An afterburner was seen as a must for a high-flying, fast-reacting interceptor, so out went the non-afterburning J-47 GE-7 turbojet, and in went an afterburning GE J-47 G-17. This power unit was operated via an electronically controlled fuel scheduling system that was intended to relieve the pilot of the tedious task of having to watch the engine behavior constantly in flight. A single throttle control lever worked through an electronic fuel selector, which determined the amount of fuel to be fed into the engine and correlated the entire engine and afterburner behavior for optimal efficiency. In the promotional literature of the day, this engine was referred to as a blowtorch with a brain. I'm not sure I'd want my blowtorch to have a brain. I prefer my tools to keep their opinions on my competence to themselves. The next thing to tackle was the radar. North American had actually started producing a version of the Sabre with a ranging radar. You can see how it was packaged in this drawing. The small dish for the AN/APG-30 was contained in the top lip above the Sabre's intake, with the mechanical computer brain and the radar transmitter between the dish and the pilot. This little X-band set, fitted in late A-model Sabres and the subsequent E and F, was actually quite revolutionary. It conferred great advantage to the Sabre pilots tangling with MiG-15s in Korea. But the APG-30 was of little use to the pilot of an interceptor searching for a bomber at night. The set had no scan mode, and even if it did have one, the tiny dish would have limited range and aperture. So the front half of the plane was significantly redesigned to fit in a search radar. The nose air intake therefore had to be lowered and reshaped to make space above it for a 30-inch dielectric radome covering the 18-inch antenna of the search radar. The AN/APG-36 was a 50 kilowatt set with a range of about 5 to 10 miles against a bomber-sized target. But the radar was only one part of the attack avionics suite. The really clever bit was the E3 fire control system, a triumph of 1940s analog computing. The idea behind the computer was to increase the pilot's chances of a hit by guiding him to the optimum point and then signaling when to fire his weapons. Getting information about these early systems is always a challenge, but my understanding is that the original idea was to fit the same Hughes E1 that equipped the F-94A and B Starfires and early Scorpions. Because of the layout of the Sabre, this would have been carried in an underwing pod. Aerodynamic concerns meant that the Air Force got Hughes to repackage the system so it could fit in the nose. This was known, creatively, as the E2. In the early days of development, it seemed that the F-86D might be armed with 4 20mm cannons. This, again, was something that was being actively considered for the Sabre in order to increase its firepower against the cannon-armed MiG-15. But the reality of attacking Soviet bombers soon dawned on US planners. Something heavier was needed to enable US interceptors to attack head-on. This pursuit curve meant that they both avoided the bombers' defensive fire and prevented deeper penetration of the defenses. Cannons just couldn't deliver enough weight of fire from this angle, as the high closure speed limited the length of burst. Rockets were the answer. So the all-weather Sabre was stripped of its guns and a retractable tray of 24 rockets was fitted beneath the cockpit. Each of these 2 3/4-inch folding fin projectiles packed the punch of a 75mm artillery shell and travelled at 2,500 feet per second. Just one hit would down a bomber. And the ADC's intention was for Sabres to attack from just 500 yards, a shotgun blast of rockets in the face of a bull. Quite where the pilot was supposed to go once he had turned the bomber into a massive cloud of lethal radioactive debris that he was closing on at 1,000 miles an hour is unclear. The tight tolerances involved in this form of attack were what required the fire control computer, which would deploy the rockets at the appropriate moment. These were all launched in a half-second burst, including the time taken for the rocket tray to extend into the slipstream. Because the Hughes E2 had been designed to direct machine gun and cannon fire, it wasn't any good for the new aircraft and was replaced by the E3. This was functionally similar to the E1 but set up for the rockets. The E3 would actually give way to the E4 after the early production F-86Ds were shipped. The difference is simply that the E4 was designed to work with the AN/APG-37, a 250 kilowatt radar set that replaced the APG-36, giving much greater range. Theoretically 30 miles, but realistically more like 15 to 20. The completed E3 was installed on the second YF-95 prototype in September 1950. It was a huge chunk of equipment, weighing over 2,000 pounds in total. That's more than 10% of the aircraft's total combat weight devoted to fire control. Hughes spent a further 2 years trying to get the system to work as advertised. In the end, they just gave up and told the ADC that it worked just great. The F-95 became the F-86D in June 1950. In October, the USAF placed an initial order for 150 of them, but the Korean War led to fears that a Soviet attack on the US mainland could come at any time, and orders for the F-86D were dramatically stepped up. By July 1951, 979 production F-86Ds were on order before the prototype had demonstrated any form of competence. Rocket firing trials had only begun in February 1951. Proving out this complex weapons system was the Sabre Dog's mission on the 25th of August 1952. Approaching the pair of B-17s in the brand new E-4-equipped Sabre Dog, only delivered in July, was Colonel Arthur DeBolt of Columbus, Ohio. The F-86D's radar searched the sky in a forward direction, sweeping back and forth and up and down in a 3.5-second cycle. He detected the B-17s around 30 miles out. As he closed, he used a joystick to point the antenna at the drone. That done, he placed a range gate marker on the target. The E-4 was now locked on. Flying heads down in the cockpit, he needed to keep the steering dot at the center of the scope and thus follow the computed lead collision course and hit the target. The time circle shrank steadily, indicating that it was nearly time to fire. At 20 seconds out, he really needed to concentrate on his flying to thread the needle. And with seconds to go, he squeezed the trigger, activating the firing circuits for the rockets. At the moment that the F-86D reached the invisible point designated by the computer's Byzantine mechanism of servos, synchro resolvers, rate gyros, and valves, the rocket tray dropped, and DeBolt felt the telltale thump as 450 pounds of rockets left the Sabre in a fraction of a second. He instinctively applied forward pressure on the controls as the fighter bobbed upwards. The scope changed to show an X, indicating the rockets were gone, then flashed a figure 8 to tell him to break off and avoid a collision. At this moment, he knew that he was only 250 yards from his quarry and he needed to get out of harm's way. For the first time in more than a minute, DeBolt looked out through the Sabre Dog's transparent bubble cockpit. He saw a B-17 in flames, descending with one of its wings ripped clean off. A success. The radio crackled. Watch for shoots. He got the wrong plane. Delivery of the F-86D to operational squadrons was painfully slow. The advanced electronics just didn't work as advertised, nor could Hughes manufacture them fast enough. At one point in 1952, North American had 340 complete airframes sitting outside its plant with no avionics to fit them with. To reassure their bosses and show off one of their hot new toys to the American public, the Air Force decided to provide a demonstration. So on November the 18th, 1952, Captain J. Slade Nash used a Sabre Dog to set a new world airspeed record of 698.505 miles an hour at the Salton Sea in California. This record was broken on July 16, 1953 by Lieutenant Colonel William Barnes over the same Salton Sea course, averaging 715.697 miles an hour. Both record-breaking aircraft were standard production F-86Ds with full armament and electronics. The faster speed of the second aircraft was made possible by a higher ambient temperature and by the addition of a ceramic liner around the exhaust nozzle. This innovation was added to the last 97 of the D-35 block of production aircraft. Based on this exhilarating performance, the Air Force ordered another 901 units. But reliability problems continued. The E-4 was very powerful, but Hughes had serious quality control problems. Systems were delivered to North American with incorrect wiring, wrong vacuum tubes, loose hardware, and the like. The electronic fuel control system was also troublesome. The entire fleet was grounded in December 1953 after 13 aircraft had been lost in fires and explosions. Long landing rolls also troubled squadrons, often deployed to shorter runways dotted around the US. To correct this issue, North American traded their knowledge on air-to-air rockets with Convair to get access to their know-how on landing chutes. These were fitted to new Sabre Dogs and reduced the landing roll from just over 2,500 feet to around 1,600. As you can imagine, all of this tinkering with the design and the ordering of many sequential blocks of aircraft at short intervals left the Air Force with a hot mess of different versions of Sabre Dog, all of them quite different from each other and requiring different sets of spare parts, different instruction manuals, and different maintenance procedures. This made for a maintenance and repair nightmare. In order to make the various production blocks of the F-86D standard throughout the USAF, a decision was made in late 1953 to withdraw all of them from combat units in stages and subject them to upgrades so that there would be more or less standard F-86D out there in the field, making maintenance and repair much less of a headache. The project was given the name Project Pullout. One by one, as their periodic maintenance became due, these early block F-86Ds were taken out of service, returned to maintenance depots or to the North American factory, and subjected to upgrades such as the installation of current electronics or the provision of the braking parachutes. By September 1955, the program was complete. Pullout ended just in time to start a new project called Follow-On. Starting in May 1956, 981 F-86Ds were upgraded to a new standard called F-86L. This upgraded earlier versions with the engine and avionics to the standard of the Block 45 Dogs and added the 6.3 wing from the F-86H Sabre Hog. This wing has a fixed leading edge with 6 inches extended chord at the root and 3 inches of extended chord at the tip. For the Dog, it was 12 inches longer than on the lighter Hog. But the main addition was the radios and data links required to integrate the Sabre with the SAGE ground control intercept system. The idea was to drastically reduce the time taken to relay instructions from various radar stations around the US and Canada to the interceptors by continuously calculating lead collision pursuit curves on the ground and automatically relaying directional instructions into the scope of the F-86 cockpit. The F-86L was a heavier aircraft than the D. Weight increased to over 20,000 pounds once 2 120-gallon tanks were hung under the wings. Tactical range was about 250 miles, roughly the same as the D. The last production F-86D was delivered to the ADC in September of 1954. The last upgraded F-86L was delivered in May 1958. In all, an unbelievable total of 2,506 F-86Ds were built. In the middle 1950s, 2/3 of the interceptors assigned to US Air Defense Command were Sabre Dogs. In fact, in June 1955, 1,026, or 73% of the command's 1,405 tactical aircraft were F-86Ds, the remainder being F-94Cs and F-89Ds. In total, the USAF acquired just over 6,000 interceptors during the Cold War. 42% of these were Sabre Dogs. And yet, for some reason, the Dogship is largely forgotten. Its Wikipedia page consists of only 3,000 words. The Starfire gets 6,500. The essentially forgotten F-89 Scorpion gets 4,600. The Delta Dagger is apparently most interesting to people. Its Wikipedia bio has over 8,100 words. Even the Ultimate Interceptor only gets 7,000. Perhaps it is because the Sabre Dog is now assumed to simply be one of the many versions of the 10,000 Sabres produced by North American rather than a standalone aircraft. It was actually the second most numerous Sabre variant, second only to the F, of which over 3,000 were produced. The difference is actually pretty marginal given how excited people get about the Sabre Dayfighter. And like the Dayfighter Sabres, it served around the world in US service and in small numbers with other air forces. Although the Dog nickname is certainly a reference to its general unreliability, it wasn't a catastrophically bad fighter, just a very limited one. Although it retained much of the agility of the Day Sabre, its armament meant that it essentially could only do one job, that of a point defense interceptor against strategic bombers flying straight and level. It was a cheap option for the ADC at a time it was desperate for firepower. The Sabre Dog only cost $383,000 per aircraft, compared to the Starfire, which cost $535,000, and the Scorpion, which was an eye-watering $1 million per aircraft at 1951 prices. Mass production of the Sabre and the use of relatively mass-produced components elsewhere, such as the radar, made it affordable to essentially dot many squadrons around the country. There were 20 wings of them at times during the 1950s. Back then, the US definitely appreciated that quantity has a quality all of its own. When it worked, the electronic engine controls also made it fast reacting. Contemporary reports say that it could be ready to light the afterburner and roll within 25 seconds of engine start. That's minutes faster than a Starfire or Scorpion. Ultimately, though, it is hard to avoid the fact that the Sabre Dog just wasn't very good. Although automated, the single crewman limited its effectiveness as an all-weather fighter. Having taken 2 years longer than planned to enter service, it was pressing on obsolescence when it did arrive. Gun-armed Starfires were serving with some distinction in Korea, while Hughes was still fiddling around with the Dogships stateside. Rocket armament would, of course, prove to be a bad idea. The 2 3/4-inch rockets were only marginal in terms of accuracy and effectiveness. With only 24 rockets on board, half that of the Starfire and less than a quarter of the Scorpion's weapon load, the chances of a Sabre Dog successfully intercepting a maneuvering bomber in the face of defensive fire and jamming was limited. Its only kill was a tragic accident. As DeBolt watched in horror, the DB-17 control aircraft hurtled down with 8 men aboard. 4 parachutes blossomed and drifted into the Gulf of Mexico. A massive search operation was immediately launched with aircraft and ships scouring the area. For the first day they came up blank, but the rescuers didn't give up, and on the second day a C-47 spotted a life raft drifting 60 miles southwest of Panama City. The minesweeper Sear sped to the area and plucked 2 of the B-17's crew from the sea. Staff Sergeant Charles D. Jones, 31 of Meridian, Mississippi, and Airman Second Class Peter R. Rosing, 22 of Ingleside, Illinois, were brought to shore, the only survivors of the crew of 8. Their sacrifice is memorialized on a plaque at Eglin. Colonel DeBolt retired as a brigadier general. The Sabre Dog was phased out of frontline service and into the Air National Guard in 1960. Large-scale deployment of the F-101 Voodoo, F-102 Delta Dagger, and F-106 Delta Dart rendered it obsolete. They could do everything that the Sabre could do, but very much better. Arrival of F-89 Scorpions, which were also obsolete but much more capable, meant that although it was a fun aircraft to fly, it was not worth the sustainment cost. Looking at the squadrons equipped with it in the ANG, it was not deployed in states that would have been on the front line of defending the US against attacks coming in over the pole, a point defense interceptor for secondary targets. Cannon-armed versions of it soldiered on for another decade in the service of other NATO nations, but their story is for another time. As perhaps has come through, the Sabre Dog is a bit of an enigma to me. The most produced interceptor of the Cold War on either side, but probably the least well covered and researched today. If you can shed any further light on its career, its role, or the deeper reasons for its fading from history, then please leave me a comment. I always love to hear them. Thanks for watching.